In this video, we will talk about how to find the eigenvalues of a matrix. So here's the formula that we use. To find the eigenvalues, we set the determinant of A minus lambda times the identity matrix. We set that equal to 0, and we solve for lambda. So let's check out an example. Let's say we have matrix A, and we want to find the eigenvalues of this matrix. Well, first we have to subtract lambda times the identity matrix. So recall the identity matrix is just the same size as this original matrix, where there are ones along the diagonals and zeros everywhere else. So that would look like this. The identity matrix for a 3 by 3 matrix. So 3 rows and 3 columns. But remember, we're not subtracting the identity matrix, we're subtracting lambda times the identity matrix. So actually, instead of ones along the diagonals, we're going to have lambdas. So it'll look like this. Lambdas along the diagonals and zeros everywhere else. So we're going to first do A minus lambda times I, where we just saw that this is lambda times I. So what do we get when we perform this subtraction of matrices? Well, we just subtract the elements in the same positions of each matrix. So we say this position, this value in row 1, column 1 is going to be 1 minus lambda. 1 minus lambda. Then the next value in row 1, column 2 will be 4 minus 0, so that's just 4. Then we have negative 4 minus 0, so that's just negative 4. Moving on to the second row, we have negative 1 minus 0, that's negative 1. Then we get negative 1 minus lambda, so negative 1 minus lambda. And then we get 1 minus 0, that's just 1. Now in the last row, we have negative 1 minus 0, negative 1. 2 minus 0 is 2, and negative 2 minus lambda. Negative 2 minus lambda. Okay, so here's our A minus lambda times I. Here's what that looks like. And remember, we have to figure out what is the determinant of this matrix. So how can we figure that out? So let's write that down here. We'll say the determinant of A minus lambda times I is equal to, so the formula for the determinant of a 3 by 3 matrix is we take this value in the first row and the first column, and we multiply it by the determinant of what's left when we remove the first row and the first column. So remember, the determinant of a 2 by 2 matrix, which is what we're left with right here, is these two values multiplied together minus these two values multiplied together. So let's see what we get. So we said we're going to do 1 minus lambda times the determinant. So let's write that here. The determinant is going to be negative 1 minus lambda times negative 2 minus lambda. And we're going to subtract from that these values multiplied together. So 1 times 2, that's just 2. Okay? Now after that, we have to subtract this value in the first row and the second column. So minus 4 times what's left when we remove the first row and the second column. So the determinant of these remaining values. So let's see what that would be. So negative 1 times negative 2 minus lambda. So this would just become 2 plus lambda. And then we have minus 1 times a negative 1, which is a plus 1. So instead of 2 plus lambda, let's just write 3 plus lambda, just to simplify things. Okay, and then the last step is we're going to add the value in row 1, column 3. So in this case, it's a negative 4 multiplied by what we get when we remove the first row and the third column. So the determinant of these remaining values. So what would that be? Well, it would be negative 1 times 2. So negative 2 minus negative 1 times a negative 1 plus lambda. So that would be minus a positive 1 minus lambda. Actually, this should be 1 plus lambda. And for this portion right here, we can see that's negative 2 minus 1, so that's negative 3 minus lambda. So let's write that instead. Negative 3 minus lambda. Okay. So what we just did there is probably the hardest part of this entire process, but basically we have to now just simplify all of this and set it equal to 0 and solve for the lambdas. So I'm going to rewrite that up here just so we can make a little room. Okay, so here's what we have. This whole mess equal to 0, and we're trying to solve for lambda. So let's start simplifying it a little bit. Let's go ahead and start inside these brackets. Let's multiply these two parentheses together. So we get -1 times -2, that's a positive 2. -1 times a negative lambda, that's a positive lambda. And then we have minus lambda times -2, so that's a plus 2 lambda. And then negative lambda times negative lambda, that's positive lambda squared. And then we have a minus 2. So we have a 2 and a minus 2, so these two are going to cancel out. And then we have a lambda plus 3 lambda plus lambda squared. So that's going to be lambda squared plus 3 lambdas. And remember, we're multiplying this with this 1 minus lambda over here. So let's go ahead and do that. So 1 times lambda squared, that's lambda squared, plus 1 times 3 lambda is just 3 lambda. And then we have minus lambda times lambda squared, so minus lambda to the third. And negative lambda plus 3 lambda is negative 3 lambda squared. So let's see what we have here. So we have a negative lambda cubed. This lambda squared and this negative 3 lambda squared is going to become a negative 2 lambda squared plus 3 lambda. Okay, so now moving on here, let's see what we get. We have -4 times 3, so negative 12. -4 times lambda is minus 4 lambda. And then over here we have a -4 times a negative lambda, that's plus 4 lambda. And then we get a -4 times a -3, which is plus 12. So check this out. This -4 lambda and positive 4 lambda, they cancel out. This -12 and this positive 12 also cancel out. So all that we're left with is this portion right here equal to 0. And remember, we're trying to solve for lambda. So let's start by factoring out a negative lambda. And what would we be left with? This would become lambda squared. This would become plus 2 lambda. And here we would get a -3, which is equal to 0. So if we rewrite this negative lambda, let's try to factor these parentheses right here. So in other words, what numbers multiply to -3 but add to 2? Well, that would be plus 3 and minus 1. So we can say this can be factored into lambda plus 3 and lambda minus 1. And that's all equal to 0. So remember, this last step, we're just trying to figure out what values of lambda actually make this left-hand side equal to 0. Well, that would be any values that make any of these 3 individual terms equal to 0. So for this first term, we can see that if lambda was equal to 0, this entire left-hand side would be equal to 0. So our first eigenvalue would be a 0. Notice that if lambda was -3, this expression would become 0, and the whole left-hand side would become 0. So our next eigenvalue is a -3. And then lastly, we can see that if lambda was equal to 1, then this expression would become 0, and this whole left-hand side would be 0. So our last eigenvalue would be a 1. So these are the 3 eigenvalues of the original matrix A.